write inside a query or build your query library. This is the quickest way to experiment and to show your team that each persona might look like in real time. Second, you might actually just decide you want to put something more permanent than a single query. For example, you can create a population or build a custom field that updates through roles so that each record carries the persona flag automatically. A rule alternative is to use an export and import process where you generate the persona flags in a query and then re-import them into Slate for long-term tracking. Today, we'll keep our focus on that first step, setting up these personas directly in a query. This gives you a working model that you can test and refine before committing to a population or field. And once you're confident in the logic and the thresholds, you can decide which of the more permanent methods best fit your institution's workflows. So we're going to spin up a query here. We're going to use our type of configurable joins. A lot of the Grimoire training will focus on configurable joins. And then we're going to use the records category, and we're going to go to person. And maybe a good primer for these trainings is actually just a simple introduction to configurable joins. I'll get that up and going at some point. So we'll build our query, and this query will return one row per person. I started with one of the clean slate environments that Slate offers, which apparently has a lot of records. Makes me feel a little silly since I definitely created a spreadsheet of dummy data. But we're going to start with looking out of state Oliver. And the primary intent here is to identify those non-resident prospects who might be distance sensitive and need targeted travel and virtual touchpoints. And we'll do this to actually build export that captures this. So we're going to add a subquery export, and we'll just say this is out of state Oliver. And we'll flip this to an existence export. So if they meet the criteria that we're going to build, we're going to say a 1 or a 0. If this was a script, you could add whatever sentence or additional details you were having here in this value if exists, because that's what's going to return in your query if you meet the filters. So for each of our personas, we are going to do a straightforward piece of Slate data, and we're also going to add an ecospherical data point. So we'll start with that Slate data right now. And we just want to see, does the state of our address, and in fact, I'm in California myself, so we'll just use California. So we're just going to join address by type and rank. We'll go with rank 1, and we'll just go with a permanent address, and we'll go California. I think when I imported my dummy data, I don't think I actually assigned a permanent versus active, but we have some matching data, so that's great. And the ecospherical data is this concept of contextual data from the student's environment. And you may be getting this through Slate itself with the American Community Survey data. You could be getting this from a vendor like Segment Analysis from College Board, not getting landscape data anymore. Or you could even generate this internally with your Slate data. Maybe you're looking at what percent of your prospective students in a certain zip code or at a certain school have a certain characteristic. So for out-of-state Oliver, since we are looking at students who are outside of California, which is just what we're treating as our institution at the moment, we want to look at what is the percent of interest in going to an out-of-state college in their neighborhood. Like I said, I had actually created a dummy data set and uploaded this. I actually added a few fields that we'll be going over. So I'm going to add another filter, and I'm going to do a comparison filter. And we'll just say, we'll just go out of state, simple, greater than or equal to, maybe we want to just do 20%. So we'll do interest, out of state interest, and I just added that to our person data table. And we will make this a real null value. We'll just say 0 if there is no value there. And we're just going to do greater than or equals to, and we'll add a literal. Don't just add your literal to the name, add it to the actual literal value. And we're just going to allow copies. And we're going to say that this value of the students in, we're just going to say maybe some kind of vendor data or data that you have internally in your system, the amount of students or adults or people in that geography have an out-of-state interest of going to college greater than 20%. So we're going to assign this both in California and out of state. I mean, outside of California. That would probably help. Not in California. And we'll just save that. So anyone with a 1 value in this column of data, we know are falling into our out-of-state Oliver persona. And next, we are going to actually look at a different persona we're going to call High Score Sally. And our Slate data that we're going to do here, we can just High Score Sally. And again, I'm just going to 1 or 0. And you could also maybe, if you just wanted to have one column and you wanted to rank order these personas so they were mutually exclusive, you could just coalesce a bunch of these subquery exports and get a single value, but then you have to kind of assign a rank to each of the personas, because if they meet multiple, which one do you want them, which preference persona would you have them in? So we're just going to do our existence here. And we're going to count the number of APs taken. And this could be something that you are maybe doing in the reader review process. And again, I'm not recommending any of these data points. I'm not endorsing any of these data points. This is just for an example. So we're going to actually look at the number of APs taken. And maybe this is from your reader review form. And maybe this reader review form occasionally had some non-numerical values in here. So we're also going to just look at a solution for that as well. So we're going to add a filter. And this is just going to be APs taken. And let's just do formula. Actually, we can probably do a comparison here, and then we'll do, yeah, there we go. Sorry, I suppose I could have done this once before going on here, but so then we'll do a comparison. Well, we have a comparison there, so we're going to do a formula here. Well, I guess we're going to do an aggregate, and then we'll aggregate a formula. So we're just going to I guess we're not. This would just be the replace. So we're going to do this a formula. So say in this APs taken field, you might have some non-numeric values in there. Maybe like a not verified or student reported, or maybe they didn't know if it was 3 or 4, so they put both of those pieces of text in. So we're just going to replace all of those non-numeric data points and maybe we just want to say the text is self-reported. Now we're going to add some apostrophes around this so it knows to look for a string value of self-reported. And then we're just going to replace that essentially with a null value. Let's go APs taken cleaned. And you could stack these if you had multiple strings that you were looking to replace. Maybe you are replacing a /, or maybe you're replacing some other piece of frequently seen text here. And we can just change this to a real data value, null value. Maybe we just drop into 0 there. So AP's taken, maybe for a high academic performance persona, we just want to say that the value is 3. And maybe we have some other kind of criteria for schools that don't offer APs, or some other element to kind of balance the academics. So then maybe this is APs or GPA or some other element that allows the student to express and demonstrate their academic qualifications in this kind of persona. So perhaps the ecospherical data then here is, again, multiple criterias. And maybe we want to look at what are the percent of adults, again, in their geographic ecospherical area that just have a bachelor's degree or higher. So again, we're just going to do another comparison filter. We're just going to do percent adults at least bachelor's. And we'll just continue to add that data point. So just search for bachelor's. Percent of adults with at least a bachelor's. And we can just make that a real just in case. And we'll drop a null value of 0. But perhaps we don't have data. Maybe perhaps this is data that's not necessarily on your data point. So what if, instead of just adding that straight data, we can embed this. As a coalesce. And coalesce is just going to say if there is no value here, and we'll just add that to string. We're not going to add a null value because then our coalesce isn't going to work. Maybe we know that the average percent of adults with at least a bachelor's is 15% in our communities, in RS data, whatever it is. So we're going to coalesce. So if they don't have this particular data point on their record, then we're just going to go with this kind of manually constructed average. And again, you could even tie that a little bit more closely with actual data, with some conditionals, formula, whatever it could be. So percent bachelor's with average fallback. And you could coalesce whatever kind of naming convention that you want to add, and we'll just do format value of real. Real just gives us the decimal points. Integers would be just whole values, which wouldn't work with a percentage unless you are adjusting the percentage up into a 0 to 100 instead of a 0 to 1 value. So we can just get rid of that raw value, raw data. And then maybe for this, we want to say it's 0.30 or 30% is our cutoff for this. So we'll just say that greater than or equals to 0.30. So either one of those criterias would identify a prospective record as a high score Sally persona. And then let's take a look at another persona here. We're going to do a campus cruiser Carla. And this is someone that might be a local prospect who can respond to an in-person touch, maybe a short notice invitation for a specific program. And so we're going to go ahead and just say campus cruiser Carla. And Campus Cruiser Carla played a pretty prominent role in the Discount Inferno, which is the musical parody based pretty loosely off of Dante's Inferno. So Campus Cruiser Carla is showing up in the Innovation Forge cinematic universe, I guess. So for Campus Cruiser Carla, we're going to look at distance from campus. And I probably should have figured out a good longitude latitude for this comparison. And if you've looked at or seen my session at the 2025 Slate Summit, or the workshop walkthroughs that I've done, or even just kind of the rehearsal video that I recorded for that, this is not a new element. I think I did a more more basic version of it, so we're going to just do a coalesce here. And I won't take too much time doing school address, then permanent address. We'll just look at the student's permanent address to our longitude latitude point. So we'll just do a formula here. And we'll give you the option to maybe do some bands here. Bands I have found to be helpful, especially for kind of segmenting. So we'll just leave that as a formula to give us a little bit more control to do our score bands. And maybe this is just distance. And what we're going to do, and I think we're still going to want to do a well, I guess we can just do a null value. If we don't have a permanent address on file, then we can just have that null value be maybe a distance element, because we're probably more likely to have null value for address for purchased records or international records that we just didn't get address on. But anyways, that's kind of neither here nor there. So we'll do distance permanent address. And we could coalesce this. If they don't have a permanent address, then check their school address. If they don't have a school address, then check down into a null value. But we're just going to do proximity by latitude and longitude. And we're just going to join by that type and rank again. We'll do permanent, rank 1. So if you have 2 addresses on file, rank 2 would be that second, whether it's priority, chronologically after the check down of which address you're pulling and comparing against. And maybe we just do I don't know I don't know longitude latitudes off the top of my head, so we'll just do that. And this will check against their permanent address and how far away that is from our longitude latitude. In this, you could just search what is the longitude latitude of your institution or any other kind of important waypoint that you're doing. So this is just going to return us a value. We're going to make that real, and null value, maybe we just use that as like a 3000, kind of segment them in possibly with international students. I'll just do that distance perm. So maybe we want to see, did I add this as the actual, I did actually add those instead of as a filter. Oh my goodness. And this is why I probably should have done this before I went live on YouTube. So we're going to say distance is less than or equal to maybe 50 miles. And we'll do a comparison. And we'll just do that longitude, latitude. And by type and rank, we're going to put that to permanent again, rank 1. And we'll assign this to some kind of random values. And we want that to be less than or equals to, and we'll just say 50 miles. So any student within 50 miles of your institution. And perhaps another element that we want to look at, because maybe this is, you have an event for a specific program, let's say a STEM program that you have coming up. So you just want to kind of see like, okay, they're close to campus, and we also want to see maybe they have a high concentration of high school graduates in STEM majors. So we're just going to do another comparison, and we're just going to look for our high percentage of students at a high school majoring in STEM, and we will make that real. Actually, let's do another coalesce. Let's add one more layer to this coalesce. So STEM majors. And we're going to coalesce this. So again, we're going to add our STEM field. And we can add our, maybe we've already looked at the data and we know that the average is 20% in the area. But maybe we have this data point on similar students. Maybe students who are at the same zip code, we just never added this data to this particular student. So we can actually run an independent subquery on your entire prospective student pool. And this allows us to take those data points from other students who might have interesting ecospherical or contextual data on their record, but just that data, just for whatever reason, hasn't made it to students that you are interested in. So we're just going to say this is an independent subquery of STEM majors, and we could do it at the same school, let's say. So I'm going to do an independent subquery because this is STEM majors at a school. So our base is persons as well. And we want that STEM data point. And you do have, make sure that you're pulling from the correct data table. And we only want to pull this for students who are in that same geography. So in this, so if this was a neighborhood data point, you could do this based off of zip code. So you can do another comparison that the zip code matches the zip code, or because this is more of a school-based element, or you could do both and get whatever data that you have available. Maybe, I mean, this particular data point wouldn't necessarily be very neighborhood specific, but depending on what the data point is. So we want to look at students who go to the same zip code. So just again, another comparison, we'll keep that as equals. And we'll go seed code. Well, it probably would help if we did some joins to schools. And we'll do a school by rank. And you can do by level of study, whatever you need to do. We'll just do by rank and school by rank for our independent. And this is our independent subquery. You don't want the data tables to be named the same as you pull up filters and exports. So it's just helpful to have change the names a little bit. So we're just going to look for, I guess it's probably going to be code. So code from our two school ones. Make sure that these match. So you're in this independent subquery that you're going to pull. You're only going to pull records that go to the same school. So we're just going to say this is a filter for same zip code, so or same school. And then we also don't want to, if again we have a mix of students who either have or don't have this data point. We want to make sure that we're only going to, and this is just going to pull that first record that's being returned. So we want someone who actually has this data. So we're just going to do exist, and we can just add our STEM, make sure we're doing that in person independent subquery again. So we're only going to pull a record if they have this data point. If not, it's not helpful to offer up this data point on a different record if they don't have the data point. So you can just say the field exists. It's a little bit more vague, reusable. If we're copying this export and using different data points. So this is an independent subquery to pull that STEM major data from another student in our data file. And we'll just make that real. Oop. And you could pull that null value of the average there. I think it's a little bit cleaner to have the different data points that you're coalescing a little bit more clearly laid out. So we're going to return this STEM major percentage. If that is not available, then we'll pull that STEM major data point from a student who goes to the same school and actually has that data point. If that's not available, then we'll just use whatever is your data specific average. And we'll just make that real. And again, you could pull that null value there, but I think it's just cleaner to have that data visually accessible, especially since you're going to have to scroll to see that null value. So we're just going to say if that STEM major's data point is greater than, let's say it's 30%. So our average is going to fall below that, so we're only going to pull students who very much so meet our criteria that do greater than or equals to is very specific for this program that you're going to be sending an email out for. So we can just say STEM greater than or equals to 30%. And we'll just do in existence. So that will be our campus cruiser Carla persona. And we're going to do one last persona, and then we'll start wrapping things up from there. And this next one we talked about earlier, this is Funnel Fiona. We want to spot those high unconverting activity students, prospective students, so you can simplify next steps for them. This kind of helps reduce friction on your call to actions with a really program-specific CTA. So we want to look at, again, another independent subquery. And we're just going to call this Funnel Fiona. And I'll remember to do this correctly this time. And we're just going to add some filters here. So we want someone with a high engagement score. So we're just going to say high engagement score. And we'll just do engagement. We'll do engagement score. And we'll do a comparison. And maybe we just want to say it's 50. And this cutoff could be changing as you go throughout your cycle. Early in the cycle, students aren't as engaging as much. So this score could be changing throughout your cycle. So make sure that you're not just choosing an arbitrary number. And we'll say that's greater than or equal to. So we have our high engagement score. And let's say that they are, so my dummy data did come through because that is a new field that I created for this specifically. But maybe we want to say they're not an applicant yet. They're really interested in us, but we haven't crossed the hurdle yet. And we're going to say they're an inquiry. If you have a data set that maybe they applied previous year, status isn't the best way. Maybe you want to do an existence for not exist, application, active period, whatever it could be. We're just doing inquiry for simplicity's sake. And then, again, maybe we just really want to focus on students who might be interested in our finance program. And we don't really have interest data on this particular student, so we're going to bounce to our ecospherical data. So we're going to do another independent subquery filter, and we'll do a comparison again for, we should have a finance, percent of adults in finance industry. Again, this is a little bit of ecospherical data to maybe the students growing up with those expectations. Try to, of course, have student-specific data whenever you can. Again, not endorsing these kinds of data for outreach or anything generally, but then we're just going to say maybe 0.05%. And again, I'd recommend pulling that independent subquery to compare against similar students who might not have the data on their record, but might have on similar students and with the same zip code, or creating an average backfall there. We've already demonstrated both of those though, so I don't think we need to do that again. Our null value of just 0%. And we're just going to say percent and finance. So now we're not going to just send them 10 emails a week. We're going to be much more targeted with program-specific emails for this particular student. because their activity is high, but conversion is stalling for some reason. And this could also be a good prospect for getting called or understanding some other contextual information as to why they might be stalling out, but helps the counselor give them a nudge.